Hey guys, this is Mrs. Harbin, and this is our presentation for Algebra 2, Section 1.4, Solving Equations. Our biblical correlation comes from Genesis 6:15 through 16, where God tells Noah, "This is how you are to build it. The ark is to be 450 feet long, 75 feet wide, and 45 feet high. Make a roof for it and finish the ark to within 18 inches at the top." We can see as far back as Genesis 6 that numbers and precision were important as Noah used these numbers and measurement systems to build the ark. And they're no less important for us today. We need to be able to measure and calculate things precisely and accurately. Our lesson objective is that you, the student, will identify the properties of equality and solve equations by applying the properties of equality. So let's take a look at some definitions. An equation is a mathematical sentence stating that two expressions are equal. An equation can be as simple as 2 equals 2. We have two expressions and we're stating that they're equal. Now in Algebra 2 we usually get a little bit more complicated. You can think of an equation as a scale, which is pictured here. Whatever we have on one side has to be on the other side in order for that scale to balance. If I put something on this side of the scale, I need to put something of equal value on this side of the scale. If I take something off of this scale, I need to remove something of equal value from this side to keep it balanced. A value of the variable that makes the equation true is called a solution, or a root. So in this expression, let's say 8x equals 16. The value of x that would make this statement true, that would make it equal, is called the solution, and our solution is 2. Or we could also say it's the root. The root of this equation is 2. Let's talk about some properties of equality. The first property is the reflexive property of equality, which says that A equals A. Think back to that first equation that I wrote, 2 equals 2. Whatever's on one side is equal to the other side. That's the reflexive property of equality. The symmetric property of equality says that if A equals B, then B equals A. If one side of the butterfly wing looks like the other side, then we can say that this side looks like that side. It doesn't matter what order we put them in, they're still equivalent to each other. The transitive property of equality says that if A is equal to B, and B is equal to C, then A must also be equal to C. A good example of this comes from the world of science. Let's say that A is a dog and B is a mammal. I'm just going to write the first few letters here. Okay, if a dog is a mammal and a mammal is equal to C, an animal, then the dog must also be an animal. So this kind of logic, called the transitive property of equality, is really important. The addition property of equality says that if A equals B, then A plus C equals B plus C. Think back to the picture of the scales that we saw at the beginning. Remember what I said? If we add something to one side of the scale, then we have to add something of equal value to the other side of the scale. So here's our scale. If this side has A and this side has B and they're equal, and I add C to the A side, I have to add C to the B side to keep them balanced. The multiplication property of equality is similar, and it says that if A equals B, then A times C equals B times C. Again, let's go back to our scales here. Kind of drew that one a little funny. All right, we've got our two scales, and they're being balanced. And I have A, and I have B. If I multiply this one by C, I have to do the same thing to the other side to keep it balanced. Two equations are considered equivalent equations if they have the same solution. The addition and multiplication properties of equality, properly applied, produce equivalent equations. Let's go ahead and solve -3 times x plus 2 equals 4 times x plus 18 minus 1. The first thing that we need to do is distribute what's on the outside of the parentheses so that we are rid of our parentheses. Once we've done that, we want to get our like terms the same. Like terms are terms that have the same variable being raised to the same exponent. If I had an x squared and an x, I would not be able to combine those because they do not have the same exponent. So I'm going to I want to get rid of this 3x on this side. So in order to do that, I'm going to add 3x. Because these are opposite numbers, I know that negative 3x and positive 3x are 0. They cancel each other out. But if I add 3x on this side, I have to do the same thing to the other side to keep it balanced, which is what I do here. That leaves me with negative 6 equals 7x plus 71. Well, I'm trying to get the x by itself, so I'd like to get rid of this 71. And the way that I get rid of a positive 71 is with its opposite, negative 71. So those will cancel out. But what I do to one side, I have to do to the other. So we're going to put a negative 71 on this side. And that leaves us with negative 77 equals 7x. Now 7x is just 7 times x. Again, I'm trying to undo what's been done to the x. How do I undo multiplication? Well, division. So I'm going to divide both sides by 7, and when I do, x equals negative 11. Using that symmetric property, I can flip this around and write my x first, equals negative 11. An equation can be cleared of fractions by multiplying both sides by a common denominator, preferably the least common denominator. And decimals can be eliminated by multiplying by a power of 10. So let's take a look at some examples. Here we have 3 separate fractions, 4, 3, and 6. And we need to find a common product that 4, 3, and 6 are factors of. So I'm going to list my products of 3 here. 3 is a factor of 3, 6, 9, 12, 15, 18, 21. I could keep going, but we'll stop there. And 4. 4 is a factor of 4, 8, 12. The same as 3. Let's see if 6 is also a factor of 12. The products of 6 are 6, 12. There we go. So I see that all of these are factors of 12. So I'm going to multiply each side, or both sides, by that common denominator. When I multiply the 12 and the 4, I know that I can simplify here. And when I multiply the 12 and the 3, I'm also able to simplify. I can simplify here as well. So let me distribute and simplify, and that leaves me with 3x plus 4 times x minus 1 plus equals 2 times x plus 3. I am then going to distribute, combine my like terms by moving sides, adding and subtracting things from different sides of the equation. Divide both sides by 5, and I get x equals 2. All right, try this one on your own. Use the trick on decimals first to get rid of decimals. Well, I want to move my decimal 2 places. And in order to do that, I'm going to need to multiply by 100. So the first thing I'm going to do is multiply both sides by 100. Okay, when I've done that, it simplifies down to this equation, which I can then combine like terms and solve for n, and I find out that n equals 7. For any of these equations, once you find out the solution to the variable, you can take it and plug it back into your original equation to see if that is still true. That's how you know if your answer is right or not. Equations that contain several variables are called formulas or literal equations. These equations can be solved for any variable using the same process. So let's take a look at one. If 7x plus 18b equals 5b minus ax, and we want to solve for x. Now we're not going to totally eliminate the a and the b, but we want to combine these in such a way that only x is left on one side, and everything else will be on the other side. So first we want to combine our like terms. When I move things around, I add ax to the left side and subtract 18b. We did kind of 2 steps in one here. I end up with 7x plus ax equals negative 13b. I'm going to factor out the x because they both have an x. So I'm like reversing the distributive property. When I factor out the x, if I redistribute, we'll see that we had what we started with, 7x and ax. So now I've got the x here, but it's still not by itself. It's still being multiplied by this 7a. I've got to do the inverse operation, which we know is division. So I'm going to divide both sides by 7 plus a. That leaves us with x equals negative 13b over 7 plus a. I've solved for x. Even though I don't have a numerical value, I have this equation rewritten in terms of x equals. When you solve for equations, first you want to clear the equation of fractions by multiplying both sides by the LCD. Simplify both sides of the equation by combining like terms. Remember, a like term has to have the same variable, and those variables have to have the same exponent. Select the terms containing the desired variable on one side. So if you're solving for x, for example, put all the x's on one side of the equation and all the other terms on the other side of the equation. Factor the desired variable out of the sum if necessary. That's what we just did with x, factoring it out. Divide both sides by the coefficient of the variable. So whatever is still being done to the variable, go ahead and divide to get the variable by itself. Today we identified the properties of equality and solved equations by applying the properties of equality. If you have any questions, be sure to see me in class.